Is this working well? Hi everyone, I'm McGarry, and the motivation for my project today was one of the fundamental human emotions, revenge. Let me explain. I started playing online chess a few years ago, and I'm a very competitive person. And if you played any online games at all, you know that competitors often aren't the most gracious winners. So whenever I would lose, I would take that as motivation to continue to train, learn my openings, get better, do tactical trainers online, and come back in a few weeks or a few months, find that user, and prove that I could beat them. Now, a lot of times, I would find out, or go back on the site and find out that they're not actually on the site anymore, and that allowed me to be pretty disappointed. So that motivated me to find out and predict user behavior on chess.com to know whether or not I could actually enact my revenge on someone on the field with that. A minor side benefit, besides being able to enact your revenge on a specific user, is being able to benefit chess.com itself. So a specific website, chess.com, understanding user behavior on a website, especially a competitive or social website, is very important to keeping people on the site. For example, you can focus your attention on the high-risk individuals which have a high probability of leaving. So that's what my model intended to do, to assign users a specific probability of leaving the site after a certain set period of time. Additionally, you can use this to attract a wider array of users by looking at these specific profiles of players who have a high likelihood of leaving, and then tailoring your site to try to meet those needs. So first thing I did in my project was define what it meant to be inactive. And so I looked at the time scale and I picked out all the users that signed up in the United States in the month of January 2018. And I looked 3 months ahead into the future, and I picked out, in those 2 weeks, were they active? Now the first thing I did was I used a piece of data from the chess.com API called last login time. And this was a great lesson in making sure to validate your data, to understand that if the data that you have is actually telling you the things that you want out of it. And it turns out this wasn't. What this actually was telling me is, when was the last time this user profile was activated? When was it last used? And when I scraped the website, every time I scraped the website, it would activate the profile. So it wouldn't give me the actual information about a specific user's activity. So instead I moved on to number of games played in that 2-week period after the 3 months that they signed up. So if they played a game within this time period, then they were active. If they did not play a game during this time period, they're inactive. So this is a player profile on chess.com. This is specifically mine. There's a lot of information here, the statistics of your rating over time, your specific rating and stats of different variations and different time controls you can play chess at, and player customization, so an avatar, your real name, location, and the country you play. So these are all the kinds of features I was looking at to try to predict whether or not a person would stick around after the 3 months. So this is my workflow. I used the chess.com API, which is fairly new, and I took the usernames for the 1,500 players in January 2018 in the US, and I placed it into a MongoDB, and then used pandas to manipulate the data further. So in order to choose the correct model in this situation, I chose between 3 different models: a random forest, logistic regression, and a gradient boosted model. So in order to pick the right model, we have to understand the context in which we're using the model. It's very important, especially in this case, where if we're predicting user churn, it's much more important that we get as many users as possible correctly predicted as going to be inactive. Because missing out on a user on a website is much more costly than accidentally predicting a user as going to be inactive when they're actually going to be active. Because the things that you would do for an inactive user would be something like reach out and give additional advertisement or deals to a person to try to get them to stay on the site. So given this, we want to increase the true positive rate as much as possible with not giving too much account to the false positive rate. So as you can see here, the logistic regression, one of the best in the area I was looking at. So for recommendations, what I found is going from a basic to a premium membership decrease the probability of becoming inactive after 3 months. And coding profile customization was another sign that they would stick around. And the percentage of rated games each player was a decisive piece of information about a player profile. Now these by themselves are just simply directions we can take. They're not saying these are causal. We would have to do further A/B testing in order to understand whether it's a causal or correlative feature. So for each project, I wanted to use the rating graph history to do some time series analysis to understand whether or not a user will stick around based on trends in their rating. For example, if their rating is going up very quickly, it's much less likely that they're going to leave, since they're being rewarded for learning and getting better. But if their rating is plateaued or is going down really quickly, they may become frustrated and leave the site even more. Thank you. My name is McGarry, and I'm taking questions.
Oh, and then you said that you ended up settling on the logistic regression model.
Yep.
Is that the one? And that was just because it performed better at. Can you explain like why you settled specifically on that one? Like, can you go into more depth?
Yeah. So, in the case of predicting churn and activity, I decided that getting the most amount of people correctly predicted as inactive is the more important factor, because maintaining users, getting new users is much more difficult than keeping users you have. So it's much more important that you have correctly predicted people that are going to be inactive. And if you get other people in that group that are actually going to be active, even if you predict that they're going to be inactive, that's not that big a deal, because you're just going to give them a little extra attention. But if you miss out on an inactive person, then you're going to miss out on that traffic, and that's much harder to get a hold of.
What are these numbers on your plot? 0.79, 0.84, 0.83.
Oh, those are the AUC.
F1, are you familiar with that one split?
All right, going to take another quick intermission of 7 minutes or so. Grab a drink, use the bathroom, and then we'll have the last 5 presentations. Thanks for sticking around.